In this equation, we're asked to, without actually solving the equation, to list all possible numbers that would have to be rejected if they appeared as potential solutions, and then to give the domain using set builder notation form. So again, all we're doing is finding out what are numbers I'm allowed to plug in and what are numbers I can't plug in. In other words, numbers that you can't plug in that would have to be rejected as potential solutions would be those that would make the bottom undefined. In other words, those that would make the bottom 0. So the first step to finding out what numbers that would be, you have to take the bottom and set it equal to 0. Now you need to make sure that everything is factored out so that you know what are all your different unique factors. So here the first two expressions are already factored, but the last one is not. This is considered a difference of square, which factors into x plus 5, x minus 5. So now that if we look at all of our factors in the denominator, we only have two factors, and that's x plus 5, x minus 5. So when we solve those two for x, then our two numbers of possible potential solutions would be -5 and +5. And those would be the two numbers that if we were to get those as solutions, we would have to reject them and throw them out because those two numbers would make the bottom undefined if you were to plug them back into the equation. So if you want to write that in set builder notation form, it's written the same way. You're basically saying that x is such that it could be any real number, but it cannot be -5 and 5. And the reason for that, if you were to plug them back in, you would see that plugging in a -5 or 5 would make the bottom undefined. So therefore, again, in this instance, the two solutions, if they were a solution that we would have to throw out, would be -5 and +5. And there you have it, finding the domain of rational equations.